Today we're going to really start to delve into proofs, and we're going to start off with the easier proofs today, and these proofs are going to be our algebraic proofs. So if you go to your reasons for proofs reference sheets and look underneath on the properties column, most of your statement or most of your reasons for your algebraic proofs, I'm having trouble talking today, sorry, are going to be underneath the properties column of that reference sheet. So let's start off with 100% of the time, and I talked about when I went over that reasons for proof sheet, that 100% of the time your very first reason for every single proof you ever do is always given. So don't ever miss this first reason. It's free points. Don't give it away. So 100% of the time you have to start off with a given. So here's our given in our first proof, and notice that it's our first statement. Then we're trying to prove that x is equal to 6, and notice that that is our last statement. And I'm also going to point out that 6 equals x is not the same as x equals 6. So there are certain steps that you're going to do in an algebraic proof that you normally would skip or kind of do in your head when you're actually solving an algebraic equation, and you can't skip those steps. So for instance, our very first statement here is our given, because this is where it came from. So our first reason is given. Then to go from here to here, we must have done something. So look at what happened. 3x plus 12 is now just 12, so the 3x disappeared. So I'm going to go ahead and put in red what you actually did to solve the equation. It's not actually part of the proof, so that's why I'm putting it in red. We wouldn't normally put this in the proof, but I want you to see what we did to both sides. So we actually subtracted 3x from both sides. And since we're subtracting from both sides, if you look at your reasons for proof reference sheet, that property is the subtraction property of equality. So to go from here to here, we must have subtracted, and you cannot abbreviate the word subtraction because it can be confused with substitution. So subtraction prop of equality. Now you can abbreviate property and you can abbreviate equality. Okay, so then the next statement, we're going from here to here. So notice that the 12 all of a sudden became 30, and the 5x minus 18 became 5x. So somehow the minus 18 disappeared from this side, and then this changed. Why? We must have added 18 to both sides to solve. So since we're adding, that is the addition property of equality. And yes, you have to put property of equality. And then to go from this statement, to go from this statement to this statement, we went from 5x to x and 30 to 6. To get there, we must have divided by 5, which is the division property of equality. And then finally, it seems like, normally if you're solving an equation, you would go directly from this step to this step. You would skip this step in between. Or some of you would go from here to here and just say, oh, I'm done, which is fine. But this is a proof. It's not necessarily a solution. So because our last statement has to match this statement, you cannot skip this, because when you divide both sides, you do get a 6 on the left and an x on the right. So then we have to go from here to here. If you look at your properties, I want you to try to identify what property that is. So pause the video, look at your reference sheet, and then restart the video. So hopefully you notice that this is the symmetric property of equality. It's not the reflexive property. If it were the reflexive property, you would have 6 equals 6. Remember, reflexive is like a reflection. If you look in a mirror, you see exactly the same thing. Well, these are not identical, so it is not the reflexive property. The left and right side are being switched, so that is the symmetric symmetric property of equality. Okay, so now we are going to look at proof number 2. So based upon what we just did, I want you to pause the video and I want you to come up with the reasons for proof 2 and then restart the video. All right, so 100% of the time, hopefully you did this on your own already, 100% of the time your first reason should be given. So that should be a give me. Then we went from here to here by subtracting 5, so that is the subtraction property of equality. And then finally from step 2 to 3, we divided both sides by 3, so that is the division property of equality. All right, now I would like you to, you'll notice that on this third proof you have no statements and no reasons. So I would like you to pause the video. I want you to come up with all of your statements and all of your reasons and then restart the video and see how you did. You should feel a whole lot more confident at this point. So go ahead and pause and then restart. All right, so hopefully you did this on your own, and so 100% of the time, your very first statement should be your given. So I'm going to start with negative 6a minus 5 is equal to negative 95. Your reason for that should be given. Then the next thing I'm going to do is I want to isolate the variable term, so I'm going to add 5 to both sides. So if I add 5 to both sides, I end up with a negative 6a on the left, but a negative 90 on the right. Since I added 5, that is the addition property. Of equality. And then finally, I am going to divide both sides by negative 6. And so I should get to my proof statement, which is a equals 15. And since I divided both sides by negative 6, that is the division property of equality. So if you did that 100% on your own and you got it correct, pat yourself on the back. Good job. All right, so we're going to turn the page and we're going to start and look at some geometric proofs. All right, so on this page, we are only going to do 2 statement and 2 reason proofs. They're pretty short and quick, and the reason why we're emphasizing these is because the progression of these little mini proofs are going to be used in larger proofs. So start to learn and study these. And what I mean by study them is if you are given this, then you know that. If you're given this, then you know that and the reasons why. Same thing. If I'm given that this is a midpoint, then I know that. All of these are things that I want you to have in your brain so we can use them in other proofs. So it seems like there's no difference between these 2 statements, but remember what the notation means. So I'm going to read it to you. This notation here means line segment XY is congruent to line segment BC. We are to prove that, and then this notation means the measure of segment XY is exactly equal to the measure of segment BC. It is a change in notation, and I'm going to explain the reason why we use this change of notation in a minute. But if you go to your reasons for proof reference sheets and you look underneath the definition column, you will see definition of congruent segments. And under the definition of congruent segments, it says segment AB is congruent to segment CD if and only if the measure of A to B is exactly equal to the measure to C to D. So the reason for going from a congruent statement to an equality statement is the definition of congruent segments. Now, I don't write my reason as a definition of congruent segments. I'm going to show you how I'm going to write that and how I would prefer you to write it so that if we have to do the converse of this, that we can easily reverse it too. So 100% of the time, your very first statement, whoops, let me get my pen, very first statement is your given. So segment XY is congruent to segment BC. And your reason, 100% of the time, well, that was given. Then we're going to go directly to the proof statement in this one. We're changing our notation from the distance from X to Y is exactly equal to the distance from B to C. And our reason is that definition of congruent segments, but I like to write it so it looks like this. We're starting from a congruency symbol and going to an equality symbol. So because we have congruent segments, I like to write that's a congruency symbol. Congruent, whoopsie. Let's just write that all much neater. So congruent segments, that's much better looking, have equal measures. So instead of saying definition of congruent segments, I would prefer that you write out congruent segments have equal measures. That way, if we were to reverse these, let's say that this was the given and this was the proof, you would be going from an equality to a congruency. Instead, you would say segments that have equal measure are congruent. So we can use this forwards and backwards. Okay, so what I would like you to do is pause the video, and I want you to do proof 5 all by yourself. It is no different than proof 4, but now you're dealing with angles. So see if you can do proof 5 all by yourself. So pause the video, do it, and then restart the video. Okay, so hopefully you did this on your own, and your very first statement is, of course, you're given. So angle A is congruent to angle Z. Reason, given. So good job if you're starting to get that down. And then we can go directly to statement 2 because all we're going to do is a change in notation, going from congruency to equality. So the measure of angle A is exactly equal to the measure of angle Z. So your reason in step 2 is that congruent, this time it's angles because it's not segments, so congruent angles have equal measures. And that's it. So good job if you got that on your own. Now let's look at the midpoint. So we're going to look at the definition of the midpoint. If you go to your reasons for proofs and you look underneath the definition column, it's the very first one, and it says M is the midpoint of segment AB if and only if the distance from A to M is equal to the distance from M to B. And isn't that what this is actually saying right here? It's saying given that M is the midpoint of segment AB, isn't that our conclusion according to the definition of the midpoint that we would have equal segments? So this is a 2-step proof. And I want you to start to understand that if you know that M is the midpoint, and remember the midpoint can be a point, a line, a plane, a segment, it's just whatever cuts that segment into 2 equal pieces, that your conclusion is that you have congruent measures or equal measures. It's not congruent in this case, it's equal measures. So statement 1, M is the midpoint of segment AB, and then that's given. Then step 2 is our conclusion. If we have a midpoint, the conclusion is we have equal segments. So the distance from A to M is exactly equal to the distance from M to B. Now I want you to notice that I'm going to use a particular reason here. If you look at your reason for proof reference sheet, look at the very first theorem, and it says the midpoint theorem. Notice the difference between the definition of the midpoint and the midpoint theorem. The difference between the two is after the if and only if statements, you've got a congruency statement for the midpoint theorem versus on the definition of midpoint, you have an equality statement. So there's a difference between those two. So you can't just use the definition of the midpoint for everything. So if you're concerned that you're going to get those messed up, you might want to actually physically write out that definition. But more often than not, I would suggest that if this is a congruent statement, meaning that you would have line segment AM is congruent to line segment MB, you would just do the change in notation for congruent segments have equal measures instead, and then you can always use the definition of a midpoint. So that's my reason here, definition of a midpoint there we go. All right, question 7. Now I want you to look at that. We've given, and I'm going to have you pause the video here in a minute, but let's just talk about what you've been given. So you've been given the measure of angle 1 is equal to 45 degrees, and the measure of angle 2 is equal to the measure of angle 1. So you have two different things in your given. How are we going to go from here to here? So I want you to pause the video. You don't have to do the whole proof necessarily, but I want you to pause the video and just look at your reference sheet and see if you can figure out what are we going to do with these to get to here. What reason are we going to use? Okay, so hopefully you paused the video, but here's our first statement. Measure of angle 1 is equal to 45 degrees, and the measure of angle 2 is equal to the measure of angle 1. Reason given. Then your second statement is going to be the measure of angle 2 is equal to 45 degrees. So I'm going to give you two reasons that you could have thought of. So reason number 1, notice that this is measure of angle 1 and this is measure of angle 1. You could actually take 45 degrees, and I'm going to write that in red here. You could take the 45 degrees here and just substitute it here, because if the measure of angle 1, notice measure of angle 1, is exactly equal to 45, then that means I can replace the measure of angle 1 with 45 degrees. And notice that that's what has been done here. Instead of this statement here, it's the identical statement, except we have replaced measure of angle 1 with 45 degrees. Okay, so your reason, if you chose to do it that way, would have been substitution property of equality. Now, I've had some students that have said, well, and I'm going to write it down here. Let's see, I'll write it down here. If you look at it vertically, measure of angle 1 is equal to 45 degrees. That's what you were first given. And the measure of angle 2 is equal to the measure of angle 1. Couldn't you look at this as if, notice how these repeat. If these repeat, remember we used last week the law of syllogism, which is the same as the transitive property of equality, so you could use those reasons interchangeably. If these repeat, couldn't I conclude that the measure of angle 2 is equal to 45 degrees? So my conclusion here would be the measure of angle 2 is equal to 45 degrees. Whoops, I missed my equal sign, because those are repeating, so I'm going to cancel those out, and I'm left with this. And isn't that what I'm trying to prove as well? So if you use this logic reasoning, then instead of this reason here, you would have said law of syllogism, or you could have said the transitive property of equality. So note here that it says there are many ways to complete a proof. This website and this link right here shows 79 distinct proofs for the Pythagorean theorem, which is a squared plus b squared equals a squared plus b squared equals c squared. So there are more than one ways to approach your proofs. So I've just given you a couple on this one. All right, so let's look at our last page for today. It's not the last page in the packet, but it's the last page I'm going to go over today. And so we're going to move on to there. All right, so on this third page, we're going to get into some multi-reasons and steps. All right, so we're going to use a little bit of our previous knowledge that we've been working with. So if you are given the measure of angle A is 90 degrees and angle A is congruent to angle Z, we have to prove that angle Z is a right angle. So I want to point out a couple of things to you. We cannot substitute 90 degrees in here for angle A. And the reason is this is a congruency statement and this is an equality statement. This is saying that the measure of angle A is 90 degrees. This does not say the measure of angle A. So we cannot replace angle A with 90 until we change this notation. So the very first thing I'm going to do after I write my given is I'm going to change this congruency notation to an equality notation so that I can use this as a substitution. So I'm doing a little bit of pre-proof strategy to kind of see where I need to go. And then we're going to go from there. So very first statement is going to be our given statement, which is the measure of angle A is equal to 90 degrees. And then I'm going to write this vertically. Angle A is congruent to angle Z. And our reason is given. Now some people might split this given apart, and you can do that, that's fine, but I don't think you're ready for that, so I'm going to keep it put together for right now. Okay, so I want to, in my next statement, because I know I want to try to substitute in this value of 90 for angle A. But again, I know that you may not see that there's a difference here, but again, that's an equality statement, that's a congruency statement. So we're going to change this notation because we know that congruent angles have equal measure. So we're going to change this to an equality statement. So then my next statement would be the measure of angle A is exactly equal to the measure of angle Z. And my reason for that is congruent angles have equal measure. And we used that previously, right, on the previous page. Congruent angles have equal measures, or measures, however you want to say it. Okay, so now that I have the correct notation, I can now take this 90 degrees and substitute it in for the measure of angle A. And here's why we're going to do that. So statement 3, I'm substituting in 90 degrees in place of the measure of angle A, and that equals the measure of angle Z. So all I did was take the measure of angle A and replace 90 degrees with it because we were told this in the given. And so the reason for going from here to here was substitution.
It's time for lunch.
Not for you. All right, so then step 4, we're almost there. If 90 degrees is equal to the measure of angle Z, can't we conclude that angle Z is a right angle? And if you look at your reason for proofs reference sheet and look at the definitions column, go all the way down to the definition of a right angle. And it says, angle A is a right angle if and only if the measure of angle A is 90 degrees. Well, we have the measure of angle Z is 90 degrees, so that means that angle Z must be a right angle. So by definition, angle Z is a right angle. And so our reason for that is definition of a right angle. Okay. Now what I would like you to do is try number 9 on your own. I'm going to get you started a little bit with the first statement, just so that you can kind of think about it. It's a little different than 8, but a lot the same. I would prefer that you try it on your own and then come back and look at the video, but I am going to start you on the first statement first. Oftentimes, if I see 3 things written out and I see some things that are repeating, like I have a measure of angle 1, note that this is not the right notation. So you can't use a direct substitution. You'd have to change the notation first. But I do see some repeats here. Angle 2. These are both congruent statements. So there's a couple of ways you could go with this. I highly suggest you look at it vertically. So the measure of angle 1 is equal to 90 degrees, and angle 1 is congruent to angle 2, and angle 2 is congruent to angle 3. So start there and see if you can finish up this proof. So pause the video, give yourself 2 to 5 minutes, and do as much as you can. It's better to put something down rather than nothing. Remember, you're trying to learn how to think on your own. So don't go directly to my answers. I want you to try to do this on your own. So pause the video, go for it. Okay, so hopefully you went for it, and doing something is better than nothing. So here is my thoughts, and you might have done something different. You'd have to talk to me about it. But right here, I see the starting of the law of syllogism. And I'm trying to get to angle 3 is a right angle. So somehow I've got to get rid of angle 1 and 2. I do know that angle 1 is 90, and I know that angle 1 is congruent to angle 2, and then angle 2 is congruent to angle 3. So right here, just with those 2, not the first one, based upon these 2 right here, isn't that the law of syllogism? Can't I eliminate these 2 that are being repeated and just state for my next statement that angle 1 is congruent to angle 3? Angle 1 is congruent to angle 3. And the reason for that is the law of syllogism. Now you could have used the transitive property. That's the same thing. Okay. Then from here, now I've eliminated angle 2 because I don't need it. Because notice here I've got an angle 1 and an angle 3 I'm trying to get to. And I can substitute in for angle 1 that it's 90 degrees, but I can't until I change this notation, because the substitution for 90 degrees is measure of angle 1. So I've got to change this notation. So we're going to do in step 3, the measure of angle 1 is exactly equal to the measure of angle 3. All right, so going here, the reason for that is congruent segments. Oh, we're not segments, angles. My bad. Congruent angles have equal measure. Equal measures. Okay? And now in step 4, I can make that substitution. Now that I have the measure of angle 1, I can substitute for the measure of angle 1 90 degrees. And that gets rid of angle 1 and leaves me with just angle 3, which is what I want. So, reason 4, substitution. Prop of equality. Now that the measure of angle 3 is 90 degrees, we can conclude that angle 3 is a right angle, because that's the definition of a right angle. So angle 3 is a right angle reason being definition of a right angle. right, the last one that we're gonna do is this one. I want you to take 5 minutes and try to do this on your own. And then you can restart the video and I'll put my proof up here. But it's somewhat similar to number 9, but we're dealing with a straight angle and you have some differences here. So pause the video, go forth and try. All right, so this is what I did, which could be different than what you did. Again, you'll have to check with me and see if what you did is acceptable. So the measure of angle Z is equal to 180 degrees. And, so I'm going to write these vertical. The measure of angle X is equal to the measure of angle Y. So I can't substitute anything in there because the measure of angle Z is 180. Those don't have anything to do with each other. And angle Z is congruent to angle X. So that was given. So I can't use the law of syllogism here yet because I have measure of X and just X. This is an equality statement. That's a congruency statement. So what I'm going to do is convert this congruency statement to an equality statement first, and then I can use the law of syllogism because I'm trying to get rid of Z and X and get just Y. Okay, so I'm going to do a change in notation. So then my step 2 is going to be let's see, measure of angle Z is exactly equal to the measure of angle X. I mean, I guess I could have changed, oh, it doesn't matter. I'm going to change that one. So I'm going to change this one into the equality statement. Reason being because this one's already the measure of. All right, so here we go, 2. The reason I did that was that congruent angles have equal measures. Okay, so then the next step, I'm going to take this one right here, this measurement statement, and this measurement statement right here. Notice how the x's repeat. So I'm going to get rid of the x's and put measure of angle Z is equal to the measure of angle Y, and that is the law of syllogism. Measure of angle Z is equal to the measure of angle Y. And my reason is law of syllogism. You could have put transitive property. Okay. Then now that I have the measure of angle Z here, can't I substitute in 180 degrees here? And now I've gotten rid of the angle Z and I'm only down to the angle Y, which is what I want because I just want to talk about Y. So I'm going to use substitution here, substituting in for the measure of angle Z, its value, 180 degrees, is exactly equal to the measure of angle Y. So that is substitution. Prop of equality. And then finally, if 180 degrees is the measure of angle Y, then by definition, angle Y is a straight angle. So I can go to my proof statement. Angle Y is a straight angle. And 5, definition of a straight angle. And we're done. So what I want you to do is go and finish practice 2-5. And that's all algebraic proof. So you should feel very comfortable with that. So good luck. You did a good job today.